Hi, it's Mark Fenyes, Omega Sinto, Foundry Machinery. I've been asked to do a short talk about our new pilot plant that we've built at our headquarters in Peterborough, UK. It consists, as you can see, of chromite separation, thermal reclamation, primary attrition, and secondary reclamation. We have always had a pilot plant here, but we've done some upgrades to it to make it easier to test people's sand, and also the layout as well is much more ergonomic than it used to be. So when we're testing the customer sand, we prefer, if possible, the customer gives us sand which is a grain size, removed of metallics, any contamination, but we know that isn't always possible. So the first stage processing, we've got a BD attrition unit, and we'll take the lump sand and we'll process it down to grain size, also remove any metallics, any ceramic contamination that might be in the sand. One of the options for getting high-level reclamation is secondary attrition. This is our USR unit. We've been manufacturing this since 2006, have over 400 units in the field. It's a very successful system, especially for inorganic or semi-inorganic systems like alkaline phenolic. Basically consists of a rotating drum attrition unit using ceramic wheels to intensify the rubbing action and removal of resin. And then we have a classification system here that takes out fines, typically anything less than 90 microns. This is our thermal reclamation unit. It's not always possible just by primary or secondary attrition to achieve the loss of ignition results that some people require. Typically aluminium foundries or steel foundries are looking for a facing sand with as minimal loss of ignition as possible. Hence the reason why we still manufacture and provide thermal reclamation plants for many people around the world. This particular unit is capable of running at 250 kgs an hour, and it also has a heat exchanger incorporated in both the exhaust air and also for the hot sand as well, to try and make it as efficient as possible. This is our chromite separation system, primarily aimed at steel foundries who use chromite and want to reclaim that sand due to the nature of it and also the cost. Mixed sand is fed into the system. The primary removal is a ferrite magnet, about 1,000 Gauss, that takes out any metallic contaminants and also any chromite that has reduced to gangue and has lost its refractoriness. The second stage is a rare earth magnet, typically 10,000 Gauss, where we're going to try and purify and separate off as much chromite sand as we can from the silica. And typically at this stage we get about 96%. The final stage is a fluid bed separator, whereby the difference in density between the chromite and the silica sand, we're managing to get 99+% chromite purity. The reason we insist so much on testing customer sand is that we believe this is a two-part system, in as much that we want to make sure, given the different types of reclamation we've got, that we're providing the best system for you, the customer. And that could be a combination of primary, secondary, even thermal reclamation, but it allows us to also to define the parameters during the test, what gives the best result of the sand. Because of this, we believe also that it's incumbent on both of us to share the costs, and we won't charge for processing the sand, but we do expect it shipped to us and taken away by the customer. And most importantly, out of all of this, we want the customer to be involved in the trials as well, to understand what we're doing and also to see firsthand how the sand is processed and also the results that we get in the sand lab. This is our sand lab. We employ a full-time sand technician because obviously any test that we're doing, we want to make sure that we're getting the results that are required. Typical testing that we'll do would be the standard gambit, sieve analysis, loss of ignition, moisture, conductivity, acid demand value. We may not get it right the first time, the testing we do, especially with secondary reclamation, so that's why it's important that we're able to test real time the results of the sand and then make any modifications to the processing of the sand to give the results that we're looking for.